Hey everybody, I wanted to create a video where you can rewind, fast forward, pause where you need to, and we're going to go over the answers to this review key. So the first graph, it is exponential, but it doesn't go on forever. It looks like they just cut out a piece of an exponential graph, so we need to be very careful when we are identifying the domain and the range. So domain, remember that means left to right. So if I'm going from the left to the right, I'm going from -2 to 0. And since my dots are closed, they are not open, I'm going to have little brackets like so. Brackets from -2 to 0. Now, if one of these dots were open, it wouldn't be a bracket, it would be a parenthesis, but since they are closed dots, I do brackets. Now, range is how far does this function go up to down. So let me zoom in a little bit. I can see the very highest point is at 27. The lowest point is at 3. So the range goes from +3 to +27. Again, they are closed dots, so I do brackets instead of parentheses. My y-intercept, it's counting by 2's. My y-intercept is 3. So that's the point 0, 3, or you could just say 3. However the problem is worded in the test, do it that way. All right, for this function here, this one goes on forever. The way I know that is because it's got arrows on the end. They go on forever. So remember, exponential functions go on forever to the left and forever to the right. All right, so this one is all real numbers, or you could say -infinity to +infinity. Remember that symbol means all real numbers. I just didn't write it all the way out. Range, that means how far does it go up to down. So remember, it doesn't actually touch the 0. I know it looks like it's very tempting to put 0 in there, but it's got an asymptote here. That means it's getting really, really, really close to 0, but it's not actually touching it. So my range has a parenthesis, 0, and then it goes up forever to infinity. You also might see it worded as, let's see, maybe from 0, y to infinity, or something like that. But just know that the 0 is not included. That is your lower limit, and then it goes up to infinity. All right, or it might say all positive numbers greater than 0 or something like that. Your asymptote is at the horizontal line, y equals 0, because it's not actually touching it, even though it looks like it is. Okay, number 3, which exponential function is graphed below? I wanted to remind you of the function. A is your initial amount or your y-intercept, so I can already point out where that is. Right here, y equals 5. So I can already tell you that C and D, it's not going to be C or D because this is exponential, and these don't look right. It's not in the right form. So also just by looking at it, I can tell that this is a decay. Remember, if it's decay, B, that rate of decay, has to be somewhere between 0 and 1. So if it's a decay, B is somewhere in between 0 and 1. That's all it means. I can look at my answer choices and I notice that answer choice B, 4, is not in between 0 and 1. That's a growth. And if you're confused about it, type this into Desmos calculator, graph it, or graph it on Wolfram. I think Desmos looks better. You'll see that B is not it because that's a growth. Okay, so it's got to be A. Number 4, the number of people that have liked Mindy's Candy Store on Instagram can be represented by this function right here. So looks like she's growing her likes on Instagram. So T is the number of weeks after the owner of the store is watching it. So maybe she's an influencer for this store and they're watching her engagement and growth rate and things like that. So here's the function, y equals 270. 1.65 to the t, where t is the weeks. Let me move that over. So remember at the beginning of the function, that 270 right there, that is my initial amount. So that is my initial amount.
Here's your Black History highlight of the day.
Oop. Sorry for that interruption. I had to pause it. We have Black History Month announcements come on during lunch period. So back to this. 270 was the initial amount. This is my my rate of growth, right? It's growing by 1.65. Now remember that formula that we learned yesterday, 1 plus R, that was whenever it was percentages. So I know that 0.65, it's got to be converted into a percentage, all right? So 1 plus R, I know R must be 0.65 or 65%. So she's having a growth rate of 65%. So let's figure out some true or falses here. The equation shows that the number of likes is increasing each week. Absolutely, it is increasing. That's true. The initial number of likes is 65. Wrong. Our initial likes was 270, so that is false. The initial number of likes will increase by 65% each week. Yep.
Good afternoon, Miles. Here's your Black History highlight of the day.
Okay, after that, there was FFA announcements and then general announcements, so I'm back. Okay, so the number of likes will increase at a rate of 35%. That is false, because it's increasing at 65%. The number of likes at the end of 1 week is 270, so that one we have to do a little bit of math, and we have to plug in 1, because this is 1 week. We have to plug in a 1 for t. So y equals 270 times 1.65 to the first. I can already tell you that this is going to be 270 times 1.65. And whatever that number is, I know that is not 270. So I'm going to say false. You can plug that into your calculator if you want, but it is not 270. The starting number of likes is 270. That is true. All right, so number 5, we're given a table and it wants us to identify some qualities and attributes of these tables. So we need to figure out if this is exponential or if this is linear. So we need to identify the pattern here. So the way I try to look at this is if it's linear, it's either going to be addition or subtraction. Exponential is going to be division or multiplication, and just by looking at it, I don't think this is addition and subtraction. Remember, you can always plot this too. So if you want to go to Desmos Graphing Calculator, you'll go to desmos.com and click on the graphing calculator. I can plot these points, -1, 1, 0, 0.25, right? Let's see, 1.0625. All right, and then I can already see it's making a curve downward. So I know that this is going to be exponential. It's going to be an exponential decay because it was curving downward. So exponential decay. Now, in order to find the rate, what we have to do is figure out the pattern. Now, these are very, very ugly numbers, so let me show you the trick. You'll start from one of these bottom points and work your way up. I'm going to start maybe at the 0.25 and the 1. The way I do that is 0.25 divided by 1. When I do that, I can see that it's dividing by 0.25. I'll do the same here. 0.0625. 0.0625. I'm typing it over here in my other browser, so I don't have a calculator handy, divided by 0.25. And you can see that it gives me 0.25. So that's my pattern here, and you can do the last one yourself, but each time I am dividing by 0.25, so my growth decay rate is 0.25, or you can say 1/4. All right, my y-intercept, that is always whenever x is equal to 0, so 0.25 yet again. So in order to write my equation, Remember that is y equals a times b to the x. A is my starting point, b is my growth or decay rate. I'm going to end up with y equals 0.25 times 1/4 to the x. Or you can leave that as a 0.25, totally up to you. But remember, at this point, we do not combine these two numbers. That is just our answer. All right. B, I can look at that equation, and I know that that's a line because it's in y equals mx plus b form. So linear, growth or decay. This is actually 4 exponential functions, but this is a negative slope, so I guess we could say it's a decay. It's really just a negative slope. My rate of change is -5, that's my m. My y-intercept is 6. Value of y when x equals 2, I have to plug in -5 times 2 plus 6. That's -10 plus 6, which would be -4. -4. All right, C, I can automatically tell that that is exponential just by the equation itself. I can look at the growth rate, and since it's bigger than 1, it's going to be growth. Now let me make a note of that. B is bigger than 1. It's exponential growth. All right, exponential growth. My rate of change is going to be that 2 right there. My y-intercept is that 7, that's my initial value. If I want to figure out what f of x is at 3, all that means is I plug in a 3 right here, and what do I get? So that's 7 times 2 to the 3rd power. That's really 7 times 8. 7 times 8 is 56. My answer is 56. All right, this one here, just by looking at it, I can see that it's linear. If you can't tell, just think of the rate of change between each of these. 14 to 17 is adding by 3 each time. My slope, oh, this is linear. It's growing, so it's a growth. My slope is going to be 3 because it's 3 over the change in x. These are always being added by 1 over here, so 3 over 1, that is my slope. Y-intercept, that's when x is 0, y-intercept is 20. So my equation for y equals mx plus b, that's going to be y equals 3x plus 20. Which graph best represents 2 times 5 to the x? Well, that is something that I would honestly plug into the graphing calculator, pull out your handy dandy Desmos graphing calculator. Y equals 2 times 5 to the x. Boom, there it goes. It's got a y-intercept at 2. Check your picture and see which one matches. I can see that H doesn't match, J doesn't match. I know you can't see my screen, but I'm just using process of elimination. Let's see. I've got a point at, let's see, trying to find a good point that I can match here with my graph. 110, so maybe I'll look for the graph that has the point 110. 110, 1, 5. So it's got to be F. All right, so just plug that into Desmos graphing calculator, figure out what matches, find some points that match here. I know that because this was 110. I found that in my graphing calculator. So number 7. All right, I'm going to have to stop this video and do another one because I'm going to run out of time.